Hello everyone, today we are going to discuss about queue using arrays. Let me share the screen to discuss about today's concept. Queue using arrays. By the end of this lecture, we can able to know what is queue and what are the applications of queue in real time, and I can able to create and implement queue using arrays. And we will be seeing about here queue introduction and what is the definition of queue and what are the applications of queue, and we are going to see about the implementation of queue also by using arrays. Coming to the definition of queue, a queue is a another kind of list. It is also a kind of list where elements were inserted at one end and deleted at other end called friend. Here, insertion can be done at rear end and the deletion is going to be performed at front end. The other name given for this queue is first in, first out. You can see this in real-time application also. Queue, that means while you're going to take the movie tickets or bus reservation, that you're going to find this application, first in, first out. And the diagrammatic representation, which is going to show you that this is an array representation. We have already seen this, and here we are going to represent front and rear, and from the rear end we are going to insert the data, and from the front end we are going to delete the data. And this is a uh, basic example of queue. You can have, if you want to take a token in the counter, you need to stand in a queue. Here we have three persons that are standing in queue, and first person is will be served first, and then only the second person will be getting chance to take the token. After completing the token taken by the second person, next the third person will be getting chance to take the token. Like this way, the services are going to be happened in the queue. And coming to the types of queues, the queues are classified into four types mainly. In that, linear queue, circular queue, DQ, that is nothing but double-ended queue, and the last one you have priority queue. But in our syllabus, we are going to discuss about these three queues only. That is linear, circular, and double-ended queue. And this double-ended queue is also known as deck. Coming to the queue ADT, we already know that ADT is nothing but it is a combination of collection of data items and the operations which you are going to perform on that data. And here we are going to consider data in the queue is front and rear, and the operations which you are going to perform are NQ, DQ, and display or traversal. And what is an NQ operation is going to do? It is going to insert an element into the queue, and DQ is going to perform deletion an element from the queue, and display, it is going to print the elements of the queue. Coming to the implementation part of a queue can be implemented in two ways. One is using arrays and another one using linked list. Already we have discussed in queue, insertion is going to be happened at a rear end and deletion is going to be done at front end. We will be seeing the procedure for NQ operation, and let us consider the name of the array which you are going to use for queue is queue itself, and the size we are going to consider up to 5, and front and rear are initialized to -1. In step 1, if you are going to observe, this is the representation of a queue, and front and rear are initialized to -1. And if you are going to observe the queue representation, that is from 0 to 4 up to n-1 index, for size 5 we have represented, and this is going to show you that that queue is empty. Now I want to insert one element into the queue by using NQ operation. In that particular case, a rear will be incremented, and we are going to read the element, and rear will be incremented, and we are going to place it in that location, memory location. In a similar way, NQ20, rear will be, we are going to read the element, rear will be incremented and insert the element. and Q30 in a similar way. Read the element, rare will be incremented and place it in its location. Then read 40 and rare will be incremented and insert into its memory location. And the last element 50, rare will be incremented, insert in its memory location. If I try to insert one more element into this, then it will be showing rare equal to size minus 1. Now we are unable to insert one more element into this queue because the size we have given is 5. The elements are filled in this, so we are going to have an overflow condition will occur. Still we work with array only, we didn't work with friend. Now see the implementation of queue. If first itself we are going to check whether the queue is full or not by checking with this condition rare equal to size minus 1. If rare equal to size minus 1, we are going to display a message queue is full or queue is overflow. Else we are going to read the element and increment the rare value and we are going to place that in that queue rare position. This is a enqueue operation. In this way we are going to implement the enqueue. And coming to the dequeue operation, now it comes to the picture of using friend also. Up to now we have used rare for inserting the elements into the queue. Now we are going to use the friend value. Initially you are going to have, you'll be in this particular position already from the previous example. Now I want to delete one element from the queue. That means that is going to be done from the front end. Initially front is positioning to minus 1. Now I'm going to increment my front value. Front is pointing to 0. Now based on the increment value, the first location, that is 0th location, 10 is 10 element is present, that is going to be deleted. Next I want to delete the next element. Then front will be incremented and then you are going to delete that element, that is 20 is going to be deleted. Now the next element which I want to delete is 30. Now increment the front value, delete the element. The next one we are going to have increment the front value, 40 is going to be deleted. And the next situation, if you are going to see, now front is pointing to 50 and red is also pointing to 50. Now I'm going to delete this element. Now the queue becomes empty. Now the condition which I am going to raise is front equal to red. In this particular case, the queue becomes empty. That means in here itself, here also we can make it as front and rear are equal. Then we can initialize front equal to rear equal to minus 1. And this is going to show you that underflow condition. Underflow is nothing but you don't find any elements in the queue. In that situation, if you are going to remove an element from, if you are trying to remove an element from the queue, that is not possible. That means queue is empty. Next, when you are going to see about the implementation part of dequeue, front equal to rear, queue is front equal to rear, the queue is empty. Else you are going to increment the front value and whatever the element you want to remove, that will be assigned to X. And if you want to print that element which is removed, you can use a printf statement to print that particular element X. Now procedure for display. Now this is a situation which you are in, right? Now front is pointing to the 0th location and rear is pointing to the 4th location. Now I want to display all the elements in the queue which is present over here. Now for that, initially we are going to verify with this condition front equal to rear. That means whether the queue is having the elements or not. At the starting itself we are going to verify. If queue is empty, we are unable to display the elements. That's why we are going to do this. Now if the queue is not empty, then we try to print the elements from the queue. Now you observe for I equal to front plus 1. What is the front value here? Front is initially it was minus 1, then after incrementing the front value it becomes 0. That means front is minus 1 plus 1. This will be showing you the 0th value. Now 0 less than or equal to rear. 0 less than or equal to 4 if this is the case. Next we are going to print the q of I. Q of I is nothing but 0 value. Q of 0 value is 10 will be printed. Next, I will be incremented, I becomes 1. 1 less than or equal to 4. Yes, the condition is true again. Now we are going to print Q of 1. Q of 1 is nothing but 20 is going to be printed. Next, I will be incremented, I becomes 2. 2 less than or equal to 4. Now the condition also true now. Now we are going to print Q of 2, that is 30 value is going to be printed. Next, I will be incremented, I becomes 3. 3 less than or equal to 4. Again the condition is true. Now you are going to print Q of I, that is 40 will be printed. Next, last one, you have I will be incremented, that is 4. 4 less than or equal to 4. Yes, true condition, 50 will be printed. Now I will be incremented, I becomes 5. 5 less than or equal to 4, the condition fails. Now it is going to print all 10, 20, 30, 40, 50 elements into the screen. Thank you for listening.